Vector, not if you keep asking. Vector magnitude and unit vectors. Given vector u, because we always use u for some reason, which is equal to u1i plus u2j. U2. U2 can do vectors. Well, I don't know if U2 can do vectors. Well, maybe. I mean, I don't know how far they got in school. So the magnitude, the definition of the magnitude of vector u is the square root of u1 squared plus u2 squared. And that's the magnitude of vector u, right? Or the size, right? Magnitude or the size. Guess what a unit vector is? Well, a unit vector is a vector with magnitude. Now guess.
No direction.
A unit vector.
Don't we have to like put this
A unit.
Oh, it's like this symbol.
Magnitude 1.
Oh.
Unit.
Oh.
Right? 1 unit. Why is there a funky hat on that?
No, we're gonna take it. I'm good.
Whoops. And so, we get u. We have this.
Oh yeah, we have that.
So if you scale a vector by 1 over its magnitude, then what's its magnitude going to become? 1, right? It's a little hat. A unit vector. Got to follow what's above. A unit vector. So how do I make a vector a unit vector? I multiply it by 1 over its magnitude, right? Which will change its magnitude to be 1.
1 or negative.
No, 1.
Oh, I don't like how you get it.
Example. Because we go from the abstract to the concrete. Okay, so for example. If u is equal to 3, negative 4, which is 3i minus 4j, just, bringing all the notation in, right? We got all these different notations. We got, column vectors, we got geometric vectors, position, well, we're not really dealing with position right here. Okay, then what's the magnitude of u? So in order to find the magnitude of u, we take u1, right, which is the 3. So it's the square root of 3 squared plus negative 4 squared. I don't know if I want to put brackets around. I can put brackets around both of them, right? It'll just remind me that when I square them, when you square something, what do you always get? You always get a positive, right? Yeah, as witnessed on the quiz yesterday.
What? Hey, I forgot,
I don't know. Well, you're doing b squared minus 4ac and somehow managing to get it wrong, so.
What?
Yeah, basically
Why not plus or minus?
what he said, right?
Because it's the magnitude.
So it's the size of the vector, right? It's not its direction. So if you think about what that means, you take the geometric vector on the grid, right? So 3i says we're going 3 units to the right, and 4 units down, 3, 4. Magnitude is this, right? Which is 3, 4, 5. right? It's going to make no sense for anybody listening, but
Oh, so it's
'cause
people
I-
that
so if we think about this, right, that you're going 3 and 4, then your magnitude 3, 4, right? 3i minus 4j. Magnitude, that's your actual vector. Pythagorean theorem. There you go. The hatchet u is equal to 1/5 of u, the vector. So if I want the unit vector, and this is my given vector, then the unit vector is what? Yeah, so it's a scalar multiple, right? I'm scaling the vector down. I'm actually scaling it down, right? To be 1/5 of its size. And everything is 1/5 of what it were, right? And so the resultant magnitude will be 1, right? Giving us a unit vector, a vector with a magnitude of 1, okay? Length of 1. So if you were to take this, 3/5 squared plus -4/5 squared, what would you get? 1. Very good. But it's also 1/5 of u, which is 1/5 of, and it could be expressed in different ways, right? And this way is 3i minus 4j, because we got to get used to expressing things in different ways, right? So this is the column vector. By this, I mean this. And this is what? What do we call this one?
It's using.
Look back in your notes.
Fine, you have your own notes.
You're not using yours.
I was right. It is algebra.
Algebraic vector.
Wait, you're telling me that I have stuff on here?
Actually, you knew that, right?
I remember some stuff.
Yeah, so from yesterday. No, 2 days ago. 2 days ago.
No, I'm not.
Oh, it was like last week almost.
Oh my god, new record.
It was last week.
Where'd you find it?
Okay.
Use black magic.
Yes.
What do you think the magnitude of u hat is?
This is 1.
1, right? But let's work it out, right? Just because we want to show this, right? So 3/5 squared. I think I'm always going to throw these things in brackets, right? Because that way if they're a negative quantity, I'll remember that it's a negative that's being squared. And if it's a positive quantity, then it doesn't actually hurt. Right? So we show, that's so lots of stuff, right? 9 25ths plus 16 25ths, which is 25 25ths, which is 1. So get that, right? We just showed that the magnitude of the unit vector is 1, because that's really what a unit vector is, right? But okay, so how do you create a unit vector, right? You have to find the magnitude of the original vector, and then you multiply it by 1 over the magnitude, and you will get the corresponding unit vector, right? Because remember, it's still going to be in the same direction, right? Just its magnitude will be 1. What should we do? Let's go to a new page. D. Who has a question?
So what's the point of finding a unit vector?
Well, what if you want a vector that's 1 unit long? What if you want to create other vectors from it that are... Watch here. W is a vector opposite to u. That would only work if with, I really should change this. With magnitude, I really should change it to 2, right? Because it's W and it's vector u, but no, it's magnitude 10 in my example. What is W, question mark. Which brings up the why. You say, why do we do this? Well, it's because I want to find this vector which is opposite to you with a magnitude of 10. And how do I do that? Well, then we say, so W is equal to negative 10. Why negative? Because it's opposite. Negative 10 times the unit vector u, right? So if we didn't know the unit vector, then we would have to run. I need 10 times the size of how big is this thing? It's 5, but it's got to be a magnitude of 10. I got to multiply by 2, but what if that was 37? And so if I find the unit vector, then I multiply it by this scalar, right? And it automatically becomes. So that's why we do a unit vector. Okay? Or this is an application why we might want to. So negative means what? Opposite direction. Okay, so that's negative 10 times 3/5 I minus 4/5 j, which is equal to negative 6I minus plus 8j. So there is vector W. Let's toss a W in here so we don't lose where we're at, which is easy to do when I'm marking your guys' stuff. What the heck are you doing here? Right? Or it's negative 10 times, and we can now use column vector, right? So that's 3/5, negative 4/5, which is equal to
The exact same thing.
negative 6. Well, they're the same, but they're different representations, right? One is algebraic, one is a column vector. Because you got to get used to both. So the more you see both, the more you know. The more you know. The more you know, the more you know. Huh. What? Okay, next. There's more. Scalar. What's a scalar? What's a scalar? What's a scalar? What do you keep saying? Right, scalar is a number. It's a number, right? What does that number do? It scales. So scalar product or dot product. The scalar product or the dot product of a matrix. It's a matrix. What matrix? Vectors. Yeah, forget the matrix. We don't even do matrices anymore.
Do we do cross product?
We don't do cross product because we are not angry.
Just kidding.
Got that one, eh? Good. Good. Those who laugh.
What?
There is such a thing as a cross product, but you have to be angry to know. It's a different definition.
Cross
So,
means being
Yes.
angry.
yes.
Good job.
No English.
I'm sorry.
Being cross is being
So
angry.
subtle. Oh, cross 是生气。哦。
Well, it's obvious now.
自己说了嘛。你用英语说的好不好？道歉。
Good? Okay, so, no, we do not do the cross product. Feel free to look it up. If you want some good, I'm going to give you a source for
Google.
no, Khan Academy.
Yeah, Con.
Khan Academy has some good vector videos.
Oh, I thought you said con.
Khan, as in the wrath of Khan.
K-A-T.
K-H-A-N. Sal Khan.
Genghis Khan.
Just Google it on YouTube.
Yeah. I mean, you can find it on YouTube, but Khan Academy's got a nice set of vector videos, which are, and I'm going to show you one in a couple of days when we get to parametric representation.
Why? Why?
She's cold. Why would she ask you to close the window? Look, it's like midwinter out there. Only people have actually shoveled the sidewalks because the concrete is warm enough to melt it all, because nobody actually shoveled. But people. Okay, the definition of dot product. So, I should at this point say just, if you got here, you could have got here by skipping like 3 minutes worth of the video to get here. Okay, so dot, if you were looking at this next year, you'll remember. I had around 15 minutes. Or just, okay, here's the definition of dot product. Now it does use a dot, okay?
Which is why it's called a dot.
Which is why it's called dot product. Not a cross, right? Not an X for multiplication, because that's actually the cross product, which we don't do. Okay, here it is. It's U1, W1 plus U2, W2. Now keep in mind, this all scales up, right? We're only talking two-dimensional vectors here. This scales up to three-dimensional, four-dimensional, five-dimensional, or n-dimensional vectors, right? So everything you look at here and everything that you kind of relate to, like you may say, well, we're doing vectors really because we could just do geometry, or we could just do coordinate geometry, we could get all this stuff. I can get you lengths and I can get you all that stuff, right? But this scales up when we go to when U becomes a three-dimensional vector and has an I and a J and a K, right? Or more likely we start to get more into column vectors, you got number, number, number. What about when you go to 4 dimensions, 5 dimensions, 6 dimensions, 10 dimensions, n dimensions? All of this scales up, okay? So that if this were 3 dimensions, it'd be plus U3, W3, then plus U4, W4, all the way up to UN, WN, okay? At which point you're starting to use computers to do this stuff because, you know, really.
We have to use the left hand rule, right?
What?
We have to use the right hand rule and the left hand rule.
Stick to physics, man.
Every time he speaks in class, I'm like, you know what? I'm even kidding. Every single time.
Kaya I'm bleeding. Sa tumamang.
Okay, so where U and W are the usual, right?
Yeah, it's like carried over.
Okay, and then this could scale up, right? So I could write U3K, U4L, and so on, or write them as column vectors as well. Or, here's another definition for dot product. U dot W is also equal to the magnitude of U times the magnitude of W cos theta. What, have you been watching the Khan Academy videos or something?
Yeah.
That's good. Keep me on track then. I just, I watched it this morning. I don't know if I remember anything. Okay, where theta is the angle between the two vectors U and W. This is kind of handy because it will give us a way to figure out the angle between two vectors U and W, right? Right? Okay, because you can work backwards. You can solve for this, right? If you know this because this is this, but that's that, so this is actually that, right? This and this are the same, okay? So, for example, okay, example, U is equal to 1, 2, not a half, and W is equal to negative 6, 3. And U dot W is equal to U1, 1, times W1, negative 6. So it's 1 times negative 6 plus 2 times 3, okay, which is equal to 0. In this case, right? I mean, this just happens to work out that way. It's not like, hey, it's always equal to 0. No, it isn't. I mean, that's not normal. Well, actually, that is normal, but, right, you get that one because you've been watching. Okay, so that's normal, but you don't know what normal is yet, so.
What?
So it's normal.
Master.
Yeah, master. Normal means 90 degrees perpendicular. Okay, so,
I still don't get it.
no, you won't. U dot W is also equal to magnitude of U, magnitude of W cos theta. Right, now knowing IB, they're going to give you all this stuff. They're really good on giving formulas, right? So, yeah, you get this like formula booklet, right? It's huge. And it's got all the stuff in there, right? But, still, you should at least be somewhat familiar with this. The magnitude of U is the square root of 1 squared plus 2 squared, which is root 5, right? The magnitude of, what magnitude? Better write that in, right? The magnitude of W is the square root of, what was W? Negative 6 plus 3 squared, which is the root of 45. Right? Root 45, which is 3 root 5, right? Good. Reducing radicals. Now, the cosine of theta is equal to 0, which means that theta is equal to what? 90 degrees, right? Cosine of 90 degrees is 0. So U dot W is magnitude of U times the magnitude of W times cos theta, which is equal to, yeah, root 5 times 3 root 5 times the cos of 90 degrees, which is 0. I know, yeah. So it's all just 0, right? That's not normal. No, that is normal. Okay? So you now have what? You now have vector magnitude. You know how to work out the magnitude of a vector. You know how to get a unit vector from a vector. You know the scalar or dot product. Okay? No cross product. We haven't done it, nor will we ever. So just keep in mind that the dot product of two vectors gives you a scalar, right? You're just getting a number out of this, right? When you take the dot product of two vectors, you get a scalar, not another vector, right? It's not like, oh, I added two vectors. What'd you get? I got another vector, right? I subtracted one from another. You got another vector, right? When you take the dot product or the scalar product, you get a scalar.